to the online lecture of Computer Integrated Manufacturing in Automobile Industry. I am Milan Trivedi, Assistant Professor at LG Institute of Engineering and Technology. We are going to continue with our earlier topic, that is robot technology. But today we are going to learn a very important theory about the robot technology, that is a robot coordinate system. We need to understand this topic just in order to understand the work envelope of the robot. By the word work envelope, I mean that in particular which dimensions the robot is required to be worked, right? The area which has been covered under the particular assembly part of the robot, or I can say the end effector of the robot. If the end effector can move in the kind of rectangular section, then we are having this different work envelope for that. If the end effector is required to move in a spherical domain, for that we are having a different coordinate system, right? So as per the application, we need to choose the different coordinate system. So let's get understand about that. The first one is a Cartesian coordinate system. If we need to have a working area in a rectangular way, then it is called as a Cartesian coordinate system. As you see over here, we are taking help of two arms, but it can be a single arm also, right? If the single arm is moving up and down, apart from that it can have a radial traverse, right? Then it will cover a rectangular section, right? So such coordinate system is called as a Cartesian coordinate system. The second one is in which a robot can move in a cylindrical domain, right? For that, the end effector is radially moved, as well as it can traverse up and down also. So if this two motion and the third motion is a circular motion, this three motions are being combined together, then the work envelope would be a cylindrical, right? So that is called as a cylindrical coordinate system. The third one is a spherical coordinate system in which we are having these three basic motions, the radial traverse as well as the vertical up and down motion. Apart from that, we can have a rotary traverse. So that will form a complete sphere, right? So if that application is required, we need to go for the spherical coordinate system. And the last one, that is a revolute coordinate system, in which, as you see, we are having a two different arms. Apart from that, a single arm, we are having this two manipulator section and a single end effector. So if this kind of mechanism is there, we are calling it as a revolute coordinate system. Let's understand in detail about that. This whenever we are using these two arms, it is also categorized as articulated configuration or jointed arm configuration. In that category, we are having the first one, that is revolute, that I had recently explained, right? We are having these two basic manipulators. In between, we are having a kinematic linkages. So as you provide the motion to that, it will form a different domain or different work envelope, right? The second one is a SCARA. SCARA is for selective compliance assembly robot arm. This is normally used to pick and place the object. If some object is coming from front line, it will pick up that and it will deliver to the another line. For that, this we are having two articulated arm, as you see over here. First and second, two linkages are there in between. So the assembly is being formed like this, then it is called as a selective compliance assembly robot arm. It is widely used in most of the industry nowadays. Now let us understand about the computer vision system. This computer vision system is a part of a contact type of sensor, right? We will have a image acquisition, we will have processing of that, and based on that it will generate a specific output by developing a statistical analysis. So in order to capture the image, we are using the cameras, right? And from the software we can do the pre-treatment, segmentation and the feature extraction. So from the image of the particular component itself, this kind of system can be useful to find out the quality check, right? There is some defect or that defect is there or not in the particular finished part. So some of the things can be evaluated. It can be segregated if found defective. It can be taken apart, right? So it is useful in order to find out this kind of things from the workpiece, to check the length, width, area, perimeter, in order to check the shape, in order to check the color, or even the combination of any of them. we are using this kind of computer vision system. So robot technology can also be useful in order to find out the quality of the component. Now coming to the application part of the robot, it can be widely used in the case of agricultural industry, automobile industry, construction industry, entertainment industry. In the case of healthcare also nowadays is extensively under the research work, that is in the case of hospitals, patient care surgery. In the case of law enforcement for the surveillance and the patrol purpose. For the manufacturing industry, we are having a wide application. For the military, for the mining purpose, we are using it nowadays because this mining industry sometimes becomes very hazardous for the humans to work in that industry. So robots can be easily replaced over that. For the transportation and the material handling, for the material transfer, machine loading and unloading, for the spot welding, for the continuous arc welding. See, according to the motion, even the robots are being classified as two categories, that is point to point and the continuous application based robot. So whenever the point to point robot is used, that can be used in the case of spot welding, or wherever the continuous arc is there, we can use that continuous arc welding. uh, Even the spray painting for the assembly work, it has been extensively used. For the inspection, this computer vision system can be used. For the laboratory purpose, we can use. If you are aware about, then in the science city of Ahmedabad, number of robots has been arrived just for this last category, that is to understand the science and engineering. So that's having a wide application of the robot. Coming to the specification of the robot, this is required to be understand just for the identification of the robot, how to identify the particular robot. Uh, these are the normal specification which has been mentioned in the case of robot, that which joint has been used, which kind of end effector is used, how many degree of freedoms are there in that, what is the configuration, that is about the manipulator you are using, then the space or the particular how much area it can be covered, that workspace work envelope, then the level of accuracy and the precision you are getting in that, the speed at which it is working, right, and the payload capacity, means if it is used for the lifting purpose, then how much force it can transmit, right. So these are the normal specifications which is given in the case of a robot. Finally, if we summarize the entire chapter of the robot technology, we come to know that we are having the different laws about the robots, we are having different generations in the case of robot. Then we understand about the different anatomy, that the different elements we are using in the case of robot. Then we go into the depth, that how many different types of end effectors are there, how many different type of drives we can use, which are the different varieties of sensors which can be mounted on the robot, right. Now this specifications actually covers all the different things which we had learned, right. Based on the application, we need to select that different components, right, and that has been specified under the specification of the robot, right. Apart from that, we already learn about the different configurations, means in what particular work envelope the robot can work, right. Based on that, you need to select the particular kinematics. Based on the kinematics, you need to select specific drives even, right. So that's all about the different particular functions of the robot. But apart from that, we are having one more thing in the case of robotics to learn, is the particular uh, that cost analysis, right. If we are using the workers, then at what particular time we will achieve the break even point if we use the robot, right. We need to pay wages to the labors on a regular basis, but in the case of robot, we just need to pay the electrical bill, right, and the robot can do the task of at least 4 to 5 peoples. So that is actually the economic analysis of the robot, right. But that's just a theoretical topic, so I'm just covering in a brief right now. Okay. Apart from that, whenever the testing of robot has been happening out, we need to be very specific about that thing. We need to have proper fencing so that it cannot harm the outer environment. So that are the number of things which is taken care of whenever we are doing the testing on the robot, right. So that's all about the entire topic of robot technology and our today's lecture. Finally, thanks for watching.